All right, welcome to a video for Math 1. This is section 11.1, which is on lines and angles. So we're going to go ahead and start out with some vocabulary. And we have this box here, this three-dimensional box that we can see. And you have to remember, in a box like this, you have planes. So each side represents a plane. Each edge here, if we continue it, represents a line. Okay. All right, so we have four definitions that we're going to look at. So let's go ahead and get started. And all of these definitions are going to reference this box. So the first one is parallel lines. Now, we have learned before about parallel lines. Parallel lines go in the same direction and they have the same slope. They don't intersect. We're going to give it a slightly more geometric definition though. Parallel lines are two or more coplanar, and that is very important, lines that do not intersect. So this is sort of the new part to this. They have to be coplanar, and coplanar means on the same plane. So if we look at, say, this plane that we had drawn here, we can look at some lines that are on that same plane. For example, line DC. Okay, so I'm going to put this as part of the examples here. Line DC is parallel to HG because they are on the same plane. Okay, could be DC and DH. Okay, DC and DH are on the same plane, so they are coplanar, but what makes them not parallel is that they intersect here at D. Okay, and there are some other cases where they may not intersect, but they may not be considered on the same plane. Okay, and that is going to be another definition. So that line right there, what is that, DI, or I think that was an H, DH, is not going to intersect with BC. Okay, they are not going to intersect, but they are also not coplanar, and so that is not parallel. Okay, so that is another word, and that is our next definition. Those are skew lines. Okay, so the formal definition of skew lines is two lines, usually we're just going to focus on two, that are non-coplanar and do not intersect. So the thing that parallel lines and skew lines have in common is that they don't intersect with each other. But what makes them different is one of them have to be coplanar, the other one they are not on the same plane. Okay? All right, so in this example we can put the example BC, and I think that's an H, DH. Yeah, that was an H. One pair. Let me show you another pair. Let's do, how about AB and CG? Those would be skew as well. Or how about AE and BC? So there's lots of pairs that we can have. Now, let me show you a case where it looks like they are not parallel, but they actually are. So look at AB and CG right here. Those are parallel. They're not going to intersect, and they are also not they are coplanar, but in the box format you don't see the plane. So let me show you where the plane is. You're going to have to draw it in. If you connect A to C and you connect this, there's a plane right there that is going to go through both of those lines. So those would actually be parallel to each other. And that was AE and CG. So why don't we write that in? AE and CG would be parallel to each other. Okay, so let's do non-examples for skew lines. So we could have two lines such as, well, we could use ones that are parallel, obviously. AE and CG, okay, are not skew. What about BF and FG? Well, those are intersecting, and so those are also not skew. Okay. Now, the other sort of case we have is what if they intersect? Well, we just call them intersecting, but we want to focus specifically on lines that intersect at a 90-degree angle, which we already have a name for that, and that is perpendicular. So BF and FG come together at a right angle. This is assuming that this is a rectangular prism box, so all the angles are right angles. So perpendicular lines is our next one. We're including it because it's going to be part of your homework, although we've seen it before. Make that smaller. Okay, they are definitely on the same plane, so it's two coplanar lines that intersect at a right angle. Okay, so going back up that picture, we could use, sorry, I can't see the letters anymore, BF and FG. Okay, so BF is perpendicular to FG. We can use that symbol here because we're talking about perpendicular. We could talk about a non-example being any of the parallel lines, right? We could put AE and CG, or I'll put the C second, doesn't matter. Those would be parallel to each other, and so not perpendicular. Or we can include the skew ones. Okay. All right, our last vocabulary word has to do with planes. So let's do parallel planes. We're talking about entire planes. So we could have this plane, and a plane parallel to it is exactly how you think it sounds. It's a plane that is parallel to it, just like a parallel line. So they are not going to intersect. Okay, so the definition would be two planes, two or more, it could be more. Two or more planes that do not intersect. Okay, so remember to name planes you use at least three non-collinear points. So we can call this plane right here, we can say that that's HGDC, or you could just say HGD. You can just use three. This one could be ABEF. We don't really have a symbol for planes. So ABEF is parallel to HGDC. Okay, so if they cross, for example, so we have these two would be parallel. Let's say we're talking about this one up top. This one and that one, they would intersect. They're intersecting. Remember, their intersection is the line where they come together. Okay, so those would not be parallel. Okay, so HGDC and ABCD would not be parallel. So HGDC is not parallel to ABCD. Okay. Now for characteristics, if you think of anything that you want to add to it, but it's good the way it is. We got the key parts here. Okay, so now let's move on to the second page. The second page, we're looking at some names of angles in 2 dimensions. So this is in 2 dimensions. This is more looking at it in 3 dimensions. Okay, so what I mean by 2 dimensions is flat. So no 3-dimensional stuff going on here. All right, so first we have a definition for the word transversal. Okay, so at the top you see transversal. Okay, let's write the definition. A transversal is a line that intersects 2 or more different lines at different points, we'll say. Okay, so you have a line and you have 2 other lines, and they intersect at 2 different places. So if you have 3 lines that all intersect in the same place, that's not what we're talking about here. Okay, so the transversal would be this. Okay, or in this picture, there's the transversal right there. And so we're going to use this one picture over and over and over. And what we have here is we have the transversal, and then we have the 2 lines that it's intersecting. And what we get is 4 angles here, 4 angles here, right? There's 4 angles, there's 4 angles. And so you're going to look at them in pairs because they have specific names to them. Now, if we just look at 4 angles created by 2 intersecting lines, right, like here, we already know a lot about this. Specifically, we know that angle 1 and angle 3 would be congruent because they're vertical. Angle 4 and angle 2 would be congruent because they're vertical. And then we have linear pairs. So angle 1 and angle 2 would add up to 180. Angle 3 and angle 4 would. Angle 2 and angle 3 would. Angle 1 and angle 4 would. So you get linear pairs as well. So those relationships are still existing. Okay, but we're looking specifically at the relationship between angles up in one group of 4 and angles in the next group of 4. Okay, all right. So we are going to color this document in. Okay, to show what the angles are. Whoops. Okay, so at this point, if you haven't gotten any if you don't have any markers or anything like that, I would suggest you try and get at least 4 colors. Pause the video, go find it, so that you can kind of color code along with me here. Okay. All right. So here we have angle 1 is this position right here. Okay. So if you're thinking of it in terms of the top, angle 1 is sort of the top left of this group right here. Okay. And now if you look at the bottom group here, angle 5 is also the top. So this is a pair. They're in the same position. And so this pair, angle 1 and angle 5, that is a pair of what we call corresponding angles. Okay, and the word corresponding works here because it's kind of like angle 1 and angle 5 are in corresponding positions. Okay, so let's find another pair. So here we have angle 2. Angle 2 is sort of the top right, and angle 6 is also top right. So we get another pair, angle 2 and angle 6. Okay, so we have 2 pairs so far, angle 1 and angle 5, angle 2 and angle 6. Do you think you know what the other 2 pairs are? If you said 4 and 8 and 3 and 7, you would be correct. Okay, so we got 4 and 8 and 3 and 7. So we're just ascribing a name to these types of angles. Okay, they are corresponding. So how would we describe these angles? Well, when you're looking at a pair, they're in the same position. You could also say they are on the same side of the transversal. Okay, so we have angle 1, you see, is on the left of the transversal, and angle 5 is on the left of the transversal. That's what I mean. Okay. All right. The next kind of way that we can match these angles up is only going to look on what's known as the interior. Okay. So you have these two lines here, and if you're only looking between the two lines, this is known as the interior. Okay. So we're not going to look on the outside. So angle 1, 2, and 8, and 7 are not part of this. But we have angle 4, and angle 6 is a pair. So angle 4 and angle 6 are known as alternate interior. Okay, so they are inside those two lines, which is where the interior comes from. And the alternate has to do with the fact that they are on opposite sides of the transversal. Okay, the other pair we could say are alternate interior would be 3 and 5. 3 and 5. Okay, so we've got 4 and 6, 3 and 5. So how would we describe these angles? They are inside of the two lines, and they are on different sides of the transversal, which is why we call them alternate. Okay, we have a similar pair, which is our next pair. This is only going to look at the outside. Okay, so if this is the interior, this right here and this right here, these are known as the exterior angles. Okay, and so one pair that we can match up is angle 1 and angle 7. So it's just like the last one. They're on different sides of the transversal, but this time they're on the exterior. So we would call these alternate exterior angles. So we have angle 1 and angle 7. And then the other one that we have, do you know what it's going to be? It's going to be angle 2 and angle 8. Okay, so it's very much like the last one. You just got to pay attention to, are they on the inside or are they on the outside? Okay, so they are on the outside of the two lines and on different sides of transversal. Okay. Next, this is also going to be on the interior. Okay, so we're focusing on the interior here, so this section. And the difference though is we are going to stay on the same side of the transversal. And so that's why we call these same side interior angles. So angle 4 and angle 5 would be a pair, and the other pair would be angle 3 and angle 6. So 4 and 5 and 3 and 6. So how do we describe them? They are inside of the two lines, and they are on the same side of the transversal. Going back up to corresponding angles, we talked about how they're on the same side of the transversal, but this is the only pair that is not all inside or all outside, right? If you look at angle 1, that's on the exterior, and angle 5 is on the interior. So with corresponding, you have one of each in every single case, okay? All right, that is it for this video. Thank you for watching.